Hello students, in this video we are going to work on the remainder and factor theorem. Let's try to accomplish this in 15 minutes. So do get ready a pen and some papers and practice along with me. The remainder theorem states that if a polynomial f of x is divided by a linear divisor in the form ax minus b, then you can find the remainder by substituting b over a into your fx. What it means is right, let's do a recap on how you can how we actually employ long divisions to find your quotients and your remainder. So your f of x is your dividend, your ax minus b is your divisor. So you will have to multiply with a quotient, right, to get some values here. And then when f of x, which is your dividend minus whatever you get, the star is by taking your divisor to multiply it with your quotient. And then what remains is this thing called the remainder. So you can actually find this remainder, this value. You can find the value of this remainder just by substituting b over a into your fx. Okay, this is what it means. So if you're going to write it as an equation, it means that f of x can be written as divisor times quotient plus f bracket b over a. This is what it means. And how do you get b over a? How do you get the value for b over a to substitute into fx? So the value to get for b over a is by letting your divisor to be equals to 0. And you will have ax equals to b and divide by a on both sides. X is equals to b over a. So this is how you find the values to substitute into your f of x. Okay, and what this statement says is if your linear divisor, if your divisor is just x minus a, and if you let x minus a equals to 0, then of course x is just a, then the remainder will just be f bracket a. Right. Right, so factor theorem states that if x minus a is a factor, then your remainder is 0. Conversely means if you're given that the remainder is 0, then you can safely say that your x minus a is a factor. There's another important concept you need to take note regarding remainder theorem, and that is, this is what I have explained earlier on. P of x is your dividend equals to your divisor times quotient plus the remainder. Right, so if the degree of your divisor is not 0, then the degree of the remainder is always less than the degree of divisor. Meaning, it means that if your divisor is linear, then your remainder would be a constant. It's ax to the power of 0, but a is just any real number, is a constant. If your divisor is probably a quadratic, then your remainder, the degree for your remainder would have to be a linear. A linear means ax plus b. Linear means the highest power of your x is 1. So a and b are just real number. Okay, so this is what it means. Okay, I should leave this on. Right. All right, so let's look at example 1. right? So you're given a function which is 2x cubed minus 3x squared minus 11x plus 6. Find the remainder when f of x is divided by x minus 2, right? So your x minus 2 is your divisor, where we're going to let it equals to 0. So you have x equals to 2. Right, so remember what I learned earlier on. If a divisor is in the form x minus 2, then your remainder will be f bracket 2. Right, which means I just substitute all the x value with 2. Okay, just substitute all the x term with the number 2. And this is what you get. And you can just easily use the calculator to work it out. Right, so that will give you negative 12. All right, so let's look at part 2. So for part 2, we need to show that x plus 2 is a factor of fx. So if you were to recall what we have learned earlier on, if x plus 2 is a factor of fx, it means that we will be getting 0 for the remainder. Right, so we're going to let x plus 2 equals to 0. And we have x equals to negative 2. So this is the value that we're going to substitute into our fx. All right, so f of negative 2 will be equals to 2 bracket negative 2 to the power of 3. And we get 0. Right, so from here we need to do a conclusion. You can't just let it equals to 0 and then without doing any explanation. Okay, so we need to explain that since the remainder is equals to 0 using factor theorem, x plus 2 is a factor of f of x. All right, so this is the first part. So for the second part, we asked to solve the equation, right? So this is where you will have to find the remaining factors, because what you are given here is a cubic equation. So for cubic equations, you're expected to get 3 linear factors, or 1 linear, 1 quadratic. Okay, right. So to find the remaining factors is either you can use the long division. If you're very good with long division, just go ahead and use it. Or you can use this method called compare the coefficients. Right, so I'm just going to use compare coefficients. Right, so we're going to let 2x cubed, this is your dividend, equals to x plus 2, right? And we're not too sure how the remaining factors will look like. So it's in the form of a quadratic. So we're going to let it be ax squared plus bx plus c. And here we can easily find the values of a, because your x multiplied with the ax squared will just give you your 2x cubed. Right, so you will have ax cubed equals to 2x cubed. So that gives you a equals to 2. So a can be easily found. So this will be 2x squared. But we can't know b yet. C can be easily found also by taking 2 times c to get 2c. And this value 2c will be equals to your constant term. Okay, the 2 times c will give you the constant term in your the fx, which is 6. So from here we can find that c is equals to 3. All right. So what we need to find now, it's the value for b. Right, so when you're going to expand the whole thing out, right, that means you're going to take x plus 2 to expand the quadratic factors. You see that you have many terms. Okay, we're just interested to compare either many terms as you have the x cubed term, x squared term, x term, and the constant. We already used up the x cubed. Remember, that's how we use it to find a. We already used the constant. That's how we find c. So we are left with either you want to compare the x term or the x squared term. So for me, I will just use compare the x squared term. So to get the x squared term, you take x multiply by bx. So that will give you bx squared. Okay, and there's also another term here when you take 2 times 2x squared. Basically, you just have to fish out all your x squared term. And this x squared term, I just need to compare with negative 3x squared. Because on your left-hand side, negative 3x squared, it's your x squared term. Okay, watch out for the negative. Make sure you include the negative. So you would get negative 3 equals to b plus 4. And from there, you can get b equals to negative 7. Right. Okay, so what we have here would be x plus 2, 2x squared minus 7x plus 3 equals to 0. And we need to solve it. All right, so to solve it means we have to find the values of x. So we can factorize your quadratic further. Right, into x minus 3 and 2x minus 1. Right, so from there, you can have x plus 2 equals to 0. That will give us x equals to negative 2, one answer. X minus 3 equals to 0 will give you x equals to 3, another answer. 2x minus 1 equals to 0 will give you x equals to half. Okay, so this is how we solved this equation. Let's look at example 2. You're given the cubic polynomial fx and it has a remainder of negative 5 when divided by x plus 1 and the remainder of 7 when divided by x minus 2. So we asked to find the remainder when fx is divided by x squared minus x minus 2. So I'd like to ask you to recall the earlier concepts we have learned. I think that is the second slide. It explains that if your divisor is a linear, then your remainder will be a constant. If your divisor is a quadratic, then your remainder will be in a linear form. And since we're given the divisor as a quadratic, then our remainder will have to be in the form ax plus b. Okay, you may want to refer to the slide number 2 to recall the concepts. So this is what is happening. I have a dividend, which is my f of x, and I can write it as divisor multiplied with the quotient, and my remainder will be in the form ax plus b. Okay, right. So if you're going to factorize your divisor, what you will get will be x minus 2, x plus 1. All right. Okay, and we are told that your f of x has a remainder of negative 5 when divided by x plus 1. So this one, if you recall remainder theorem, what it's saying is f of negative 1 will gives you your remainder, right? F of negative 1 gives you remainder, and this remainder is negative 5. Okay, so we are given likewise for this, f of 2 is a remainder, and my remainder is 7. So I'm going to use these two pieces of information to substitute into my equation 1 so that I can find my unknowns a and b, right? So I'm going to substitute x to be -1. So when I substitute x to be -1 here, you will see that I would have 0 here. This will be 0. 0 times x minus 2 will be 0 times qx will be 0, right? So this whole chunk of thing will end up getting 0, right? So I would have 0 plus a bracket -1 plus b equals to f of -1, which is -5. And I would have an equation involving a and b. Okay, call it 2. Similarly, I'm going to substitute my x to be 2. So when I substitute x to be 2 here, you will see this is gone. The whole chunk of thing will be gone. So I have 2a plus b equals 7. Okay, I'm going to call this equation 3. And I'm going to use elimination method, equation 2 minus equation 3. To get okay, so a is equals to 4. So you can substitute equals to 4 into equation 3, and you get b is equals to 7 minus 8 gives you -1. So therefore, your remainder will be equals to ax plus b, which is equals to 4x minus 1. So this is how we do question 2. Right, let's look at example 3. So example 3, we're given a cubic equation, and it's equals to this divisor multiplied by your quotient and remainder. So this is your remainder. Okay, right. So this is actually a scaffolded versions of example 2. All right, if we were to remember what we have done in example 2, we said something like we have a divisor which is a quadratic. Quadratic means the highest power is 2. Then our remainder is linear. Highest power of x is 1. Okay, so we asked to find the remainder when it's divided by x squared plus x minus 1. So basically, we asked to find ax plus b. So we need to find the value of a and b. Right, you will see that we can't factorize your x squared plus x minus 1. Why you can't factorize it? If you were to find the discriminant is to determine what kind of roots the equation have. Oh, you would get 1 plus 4, 5. Oh, it's more than 0, so 2 real and distinct roots. Okay, but yes, we can factorize it. But if you factorize it, I think, if I'm not wrong, you will end up getting irrational number. Okay, you get irrational number. You can try it. You can use this formula, quadratic formula. Okay, try it and then you will get irrational. All right, so we're not going to factorize it. So what we're going to do is we're just going to substitute in certain values. So first of all, I'm just going to substitute your x to be 1. Because if I substitute my x to be 1, then basically I can just make this guy, make this factor 0. So I'm going to let x equals to 1. So I would have 1 to the power of 3 plus 1 minus 4. This will be 0. All right, so I would have the first equation 2 minus 4, negative 2. So call this equation 1. All right, then you can just use some other values for x. Probably can use 0, which is easier. So I will have left hand side negative 4, negative 1, negative 1. Oh, and then I just eliminate my a so I can find my b directly. So b is negative 4 minus 1, negative 5. Right, so I'm going to substitute b equals to negative 5 into 1. And I would have a to be 3. Right, so therefore the remainder is equals to our ax plus b, which is just 3x minus 5. Right, let's come to example 4, which is also the last example of this video. Right, so we have in this example 4, we asked to form the polynomial. Okay, we need to form the polynomial, but we're given some conditions. It says that the highest power of x is 2x cubed. So it is a cubic polynomial. All right, yeah, it's a cubic polynomial. It got 3 roots, negative 1, 3, and k. And given fx has the remainder of 20 when divided by x minus 4. Okay, this is another piece of information given, meaning f of 4 is equals to 20. Okay, right. Find the values of k. Okay, so let's put down all the informations that we're given. First of all, we are told that f of x, when f of x is equal to 0, right, when f of x is equal to 0, the possible values of x is negative 1, 3, and k. The roots refers to the values of x when f of x equals to 0. Okay, so what we are saying is that x, the values when f of x is equal to 0, right, x can be negative 1, x can be equals to 3, or x can be equals to k. So if you're going to put it, this is what we are saying, right? Right, when you let it go to 0, this is how I get x equals to negative 1, x equals to 3, and x equals to k, right? Okay, however, we need to consider also this particular condition given here, because when you take x times x times x, it gives you x cubed, right? But x cubed meaning the coefficients of x cubed is 1. So when you expand it, that means your first term is 1x cubed. Okay, the first term of your cubic equation is 1x cubed, which does not satisfy this condition. They want the coefficients of x cubed to be 2. So all we need to do, just we multiply a 2 here. And it doesn't matter if you multiply 2 on the left and then times 2 on the right. It does not affect your right hand side, because 0 times 2 will just give you 0. But it makes a lot of difference to your left hand side, because then this will become your fx. And there's no need to expand it. There's no need to expand it. So to find the values of k, we need to use this information given. F of 4 equals to 20. Right, so all we are saying is we just have to substitute x to be 4. Equate it to 20. 4 minus k, 20 divided by 2 times 5 is 10. So 20 divided by 10 will gives you 2. And here our k will be 2. Right, so this is how we do it. Then for part B, find the remainder when f of x is divided by x plus 2. Okay, so what we need to do here is to find the remainder of f bracket negative 2. The value, that means the remainder is a value when we substitute x to be negative 2 into our fx. So which is equals to, so this is our fx, right? So I'm just going to substitute my x to be negative 2. So negative 2 plus 1, negative 2 minus 3, negative 2 minus k I found earlier on to be 2. And you can just easily use a calculator to work the value out, right, which gives you negative 40. All right, so this is how we do the last example. So right, so happy learning.